Hey, tech professionals. Today I'm diving into the key challenge of achieving artificial general intelligence, or AGI cross-domain pattern recognition. So, what's the big deal with pattern recognition? Well, current AI is pretty good at recognizing patterns, but only within a specific domain. Think about how GPT-4 predicts language patterns or how vision models identify images. They're specialists in their own fields, but don't exactly excel at stepping out of their comfort zones. But AGI? It needs to be a jack of all trades. It has to recognize and generalize patterns across different domains. Imagine an AI that understands the concept of structure not just in a sentence, but also in physical objects. One major roadblock is that current AI lacks unified representations. Each domain, text, images, sound, has its own data representation. There's no common ground where these different kinds of data can meet and interact. Humans, on the other hand, can easily link the shape of an object to its description and even to its sound. Next, let's talk about abstract and causal reasoning. Humans excel at extracting abstract features and understanding cause and effect relationships. For instance, we know that gravity affects both a falling apple and a rolling ball. Current AI? Not so much. It's great at spotting correlations, but often misses the underlying causal mechanisms. Transfer learning is another weak spot. While models like GPT-4 can generalize within language tasks, they struggle to apply that knowledge to entirely different domains. Recognizing the similarity between balancing a chemical equation and a physical seesaw requires a level of analogical reasoning that current AI lacks. So, what's the solution? First, we need a unified representation framework. Think multimodal models with unified embeddings where different types of data are mapped into a common vector space. This would allow an AI to understand that a picture of a cat, the word cat, and the sound of a cat's meow all refer to the same concept. Next, dynamic and continual learning is crucial. AI should be able to learn continuously and adapt without forgetting previous knowledge, much like humans do. Meta-learning, or learning to learn, and lifelong learning models can help achieve this. Analogical and relational reasoning are also key. Combining neural networks with symbolic logic can bridge the gap between perceptual data and higher-order thinking. Imagine using graph-based representations to encode relationships and generalize abstract patterns. Causal inference mechanisms are essential too. AI needs to move from correlation to causation. Causal graphical models and interventional learning can enable AI to predict outcomes and simulate what-if scenarios.